Hello. In this video, I'm going to discuss the easy questions in SLMC4 paper given last year. Now, SLMC4 was introduced uh, last year, and this is the only past paper available, the last year one. So let's look at the paper. Let me share the paper with you. Right. Hope you can see the paper. Now, first of all, a little bit about the competition and its structure. So this is for grade 3 and 4 students. This is a multiple choice question paper. It has 30 multiple choice questions, and you have to answer in 90 minutes to all the questions. And there's a scoring system, right? For the easy questions, you get 5 points, right? And for the medium questions, you get 6 points. And for the hard question, you get 8 points, right? So that's the scoring system. So let's look at the questions, the easy questions, right? So the first question here is number 1. So now as you watch this video, right? So I'm going to do this problem, right? So you need to pause the video and do it yourself, the question, and find the answer and check what I do. So that's the best way to learn, right? All right. So the question asks, what digit should replace the letter A so that the following calculation is correct? So here, 20 plus 8 is 23, right? It's a bit of weird, right? 20 plus A, right? So A here actually stands for a digit. It says what digit should replace the letter A, right? So it's actually the letter A is used to actually stand for this digit, which is what you need to find. And when you add that digit to 20, you get 23, right? So this is a very easy question. You can actually figure this out by simply counting from 20, right? So because it's a digit, right? So when you add this digit, so what are the digits, by the way? Digits. So we have 10 digits, right, in our number system, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, using these 10 digits, we can write any number, any big number, right, you can think of, right? So that's actually a beautiful thing, right? Using only 10 symbols, 10 digits, we can write any number, all right? So what do you have to add to 20 to get 23? So you can count, right? So, 21, 22, 23, right? So we have to add 3, right? To 20 to get 23. So the answer is 23, of course, right? Now you can actually think of this in other ways, right? So you want to add something which is denoted by A, right? This something, right? And you get 23. So what is this something? What is this letter A stands for? So try to find out, we could actually do something like this, right? So if this something added to 20 gives 23, and if you take away 20 from 23, right, you get that something, that what this letter A stands for, which is 3, right? So now this addition, right, became a subtraction problem, right? So even though it is easy, you can actually think different ways of doing this, right? Okay. So I hope actually this, gives you no difficulty at all, right? Okay. So let's move on to the next question. Number 2. How many bananas should be removed from the following fruit bowl to have equal number of bananas and apples, right? So the fruit bowl, we don't see a bowl here. We just see 3 bananas and 2 apples, right? Doesn't matter, right? Because we can imagine that these are actually fruits in a bowl. All right. And it says that how many bananas should be removed so that the number of bananas and apples become equal. Right now, they are not equal, right? So we have 2 apples and 3 bananas, right? So of course, 2 is not equal to 3, right? But if you take away some bananas from 3 bananas, we can get it to equal to the number of apples, right? Now, the number of apples are fixed, right? We cannot change that, but we can actually remove bananas so that the number of apples and number of bananas are equal. Now, as I said earlier, you need to pause the video and do it yourself and then check the answer. All right? Pause and do. All right. Hope you worked it out. And how many should be removed? How many bananas should be removed? Well, for the number of bananas to be equal to 2, which is the number of apples, we need to remove 1 banana, right? So the answer is A, 1 banana, right? Okay. So that's also an easy question, right? Okay, let's move on to the next question. Number 3, how many more apples and bananas should be added to the following fruit bowl so that 10 people can have an apple and a banana each? Right, the same fruit bowl, right? But now we want to feed 10 people, 1 apple and 1 banana, right? Right now we have only 2 apples and 3 bananas. Now, how many we need, how many bananas we need, how many apples we need to give 1 each to 10 people? So we need 10 apples, 10 bananas. Right now we have only 2 apples, right? So 2 apples, right? And then to find out the number we need to add, right? So we need to subtract 2 from 10. We need to take away 2 from 10. So 10 minus 2. Take away 2 from 10. And it is 8, right? So we need 8 apples added to the football. And we have 10 bananas needed, and 3 are there. So we need to subtract 3 from 10. So we need 7 bananas added to the football, right? So the answer is 8 apples and 7 bananas, right? So that's also easy, right? Now don't worry, you will get some challenging and interesting questions, right? Okay, for the moment, let's move on to the next question. How many more apples should be added to the following fruit bowl so that the number of apples is as same as thrice the number of bananas? Now the same fruit bowl, right? But now we need to add a certain number of apples, right? So that the number of apples is as same as thrice the number of bananas. Now there's a phrase there, the thrice the number of bananas, right? So we should be able to understand it. Twice the number of bananas. So that means 3 times the number of bananas. And we have 3 bananas. So 3 times, and we need to multiply 3 by 3, right? And this we know that 9, right? And by the way, 3 times 3 means that we have to add 3 to itself 3 times. So this is the same as you add 3 to itself 3 times. Actually, we add 3, right? 3 times, right? So we need 9 bananas in the football. Sorry, that's the number of the thrice the number of bananas is 9, and the number of apples is 2, right? Again, we need to do a subtraction, right, to find out the number of apples that should be added, which is 9 minus 2, and that is 7. So if you add 7 apples to the football, right, then the number of apples is twice the number of bananas, right? So you have to actually to get through these words, understand them, twice the number of bananas, what it means, right? You need to turn that into math, right? So that you can do the problem, right? So the answer is 7 apples, right? Okay, so let's move on to the next question, right? So here Nerushi thinks of a number and adds an even number to it. She gets an odd number as the answer. Which of the following could be the number she thought, right? Now here, we need to know what even numbers are and what odd numbers are, right? Right, now we have these whole numbers, right? Starting from 1, right? 1, 2, 3, 4. Likewise, it goes on forever. There is no end, right? And then we can categorize these numbers, right, to 2 lots, right? So 1, 2, 3, sorry, 1, 2, 3, 4, 5, 6, 7, right? 3 dots to indicate that this goes on, right? So we can categorize, right? So we say a number is even, right, if we get that many apples, right, as the number, and if you can divide them into 2 equal piles, right, then that number is an even number, right? For example, if you take the number 2, right, and if you take 2 apples, we can actually divide that into 1 apple each, so that we get 2 heaps, 1 apple in each, and they are equal. The same can be done for 4 apples, 2 apples in each heap, and they are equal, right? And so is 6. But you can't do that for 1. Of course, you can't divide 1 apple, right? Of course, you can, but you cannot cut them, right? Right. So that's not an even number. What about 3? Well, again, whole 3 apples, you cannot cut them. So if you, how many ways you can actually put them into pies? 3 apples. So it could be just 1 apple in 1 heap, and in the other one, 2 apples. Right? There's no other way. Right? So you can see that 3 apples cannot be divided into 2 heaps of equal number, right? So that's an odd number. Not an even number, odd number. So all the numbers that are not even, right, are odd numbers, all right? So we have 2 kinds of numbers, right? Even numbers and odd numbers, right? Now what happens when you add two even numbers, like we add 2 and 8, get 10. Again, an even number, right? So is it always true that when we add two even numbers, you get an even number? Let's try one more, uh, one more pair, right? Let's add 6 and um, uh, 10. You get 16. Again, an even number, right? So it is actually true for any pair of even numbers. When you add them up, you get an even number. So when you add an even number to an even number, you get an even number. It's like a rule, right? It is always true, right? I mean, there are how many pairs of numbers are there? Even numbers of pairs of even numbers. There are lots of pairs of even numbers, right? Infinitely many, not finite. But it doesn't matter how many are there. Any such pair adds up to an even number, right? Now, how do we know that? It is always true that, always when you add an even number to an even number, you get an even number. Now, think about it, right? If somebody from, Mars, a Martian, asks, us, well, how do you know that it is always true, right? Well, I'll leave it to think. And numbers which are not even odd numbers, right? And what happens when we add two odd numbers? Two odd numbers, right? So let's say we add 5 to 7. We get 12. 12 is an even number. And we add 9 to 7. We get 16. Now, is it always true that when we add two odd numbers, we get an even number? So if you look at the number of pairs of odd numbers, again, many pairs. And doesn't matter how many pairs are there. So if you add two odd numbers, right, you get an even number, right? So we can actually, again, that's a rule. So we can sort of write these rules like this, shorthand, right? Um, so we can write even plus even is even, right? And odd plus odd is odd. Now, if a Martian says this, I mean, he will think that, this is very odd. Because how can be even plus even? Two words, and there's a plus sign, right? But we know what it means. What it means is that an even number plus an even number is an even, right? So as long as we know what we are doing, that's fine, right? So we don't care about what the Martian would think, right? All right. So how about if you add an even number to an odd number, right? So let's take a few examples, right, to see what's going on. So 5 plus 6, we get 11. So we added an odd number and an even number. We got an odd number. Is it always true? Let's see. So we add, okay, let's add now, okay, 9 to 8. What do we get? We get 17, an odd number, right? All right. How about, we first write an even number, 12, and plus an odd number, 9, we get 21. Again, an odd number. Now, is it always true? Yeah, that also happens to be always true, right? No matter what you choose, if you add an odd number to an even number or an even number to an odd number, you get an odd number. So we'll write it like this: even plus odd is odd, and odd plus even is odd, right? So again, this is okay because we know what we mean, right? Otherwise, there's no meaning here when you have the word even plus word odd and it's equal odd. That's very odd, right? For somebody who doesn't know uh, what we are doing here. All right. Now, this you can easily remember, right? Um, how do you remember? Now, each person remembers things differently, right? So I remember this as, so if the two numbers are the same type, sorry, I actually may have done a mistake here, right? So odd plus odd is even, right? That's a mistake, right? So two numbers are the same type, then you get an even number if you add them up, right? That's why, I saw the mistake because I saw that odd plus odd is odd. No, it is even, right? So if they are mixed, types are mixed, even odd, odd even, then again, always odd, right? So that's how I remember. You might remember in a different way. Doesn't matter as long as you remember. So then here, Nelushi thinks of a number and adds an even number. So if she thought an even number, right, then she has to get an even number because the same type, even is even, right? But since she got an odd number, it has to be an odd number. And luckily, only one odd number is there, right? All the others are even. 102, 94, 88, 76 are even. And this is the only number, and that has to be the answer, right? Okay, so that was interesting because we were able to think about the behavior of even and odd numbers, right? And then we were able to find the answer. Okay, right. Now, the next two questions are about a company's family, right? Let's see what happens there. Now, again, you need to do the problem, pause the video and do it before you watch what I do, right? So, number 6, in Kamala's family, there are 11 children. Now, she means Kamini, has 6 sisters and 4 brothers, right? Excluding her, right? Now, she is not her own sister, right? So, she has 6 sisters, doesn't include her, and 4 brothers. The brother Anil is youngest in the family. How many brothers does Anil have? Well, if there are only 4 brothers and Kamini is not a brother, right? And if Anil is one of them, he has 3 brothers. It doesn't matter whether he's the youngest or not, right? So the answer is 3. Okay, and he has 3 brothers, so that's quite easy, right? And now the next question on the same family, right? Now the brother Anil is the youngest. Yeah, same information. Now we are told that Anil's brothers are Sunil, Bill, and Samar. Well, now somebody can actually find the answer to number 6 from number 7 because it says Anil's brothers are Sunil, Bill, and Samar. So 3 brothers. The answer we got, right? Sunil has 7 younger sisters and 3 younger brothers, right? So that means altogether he has 10 younger siblings, 7 plus 3. Then that means he is the only other one, and he has to be the eldest. So the eldest is Sunil, right? Okay, a little bit of logical thinking, right? So interesting, but not difficult, right? All right. So we go to the next question, number 8. What is the thousands digit in the number 23,567, right? Now, we talked about digits at the beginning, and this is thousands digit, What is this thousands digit? What kind of digit is that? Right? Now, these are actually digits which are in the thousands place, because we have this wonderful number system, right? Which actually uses a place value system, right? Depending on the place, the digits have different values, right? Now, let's take, this number two, what is that? 23,576, right? So we read the numbers from left to right, right? Now, first we have a 2. Now, that is not just a 2, right? It is in the, from right, right? From here, it is in the 5th place, right? So this is the 5th place from the right. And that is the 10,000s place. So whatever digits here says that there are 10,000s of me, right? 10,000. So there are, since we have a 2 there are two 10,000s, right? And if you look at this digit here, again, not just 3, it is in the thousands place. From the right, the 4th place. So it says that there are 3,000s, right? There are 3,000s here. I'm actually, this digit 3 says that I'm representing 1,000, and there are 3 of them, right? So what is the thousandth digit? It is actually 3, right? So the answer is 3, right? So we'll actually have more questions on the place value system, right? So we'll learn more about this wonderful number system, right? Which actually uses only 10 symbols, 10 digits to write any number you like. Doesn't matter how big that number is, you can write using just 9 symbols, right? Okay. So we go to the next question. What is the largest 2-digit number that can be formed by erasing 2 digits in 2023, right? Again, it says 2-digit number. Yeah. So it means a number which has only 2 digits, right? So what are the 2-digit numbers? Well, the first one I can think of is 10, right? Because if you take the numbers 1 up to 9, just single-digit numbers, right? 1-digit numbers, right? But you don't call them 1-digit numbers, you simply say digits, right? But then when you have a number consisting of 2 digits, well, we say call them 2-digit number. And like as we have 3-digit numbers, 4-digit numbers, right? So how many 2-digit numbers are there? Just for curiosity, right? So we can write the 2-digit numbers, right? So 10, 11, 12, and the list goes on, and it ends up at 99, right? Because the next one is 100, which is a 3-digit number, right? So how many numbers are here? Well, think about it, right? Now, what is the largest 2-digit number that can be formed by erasing 2 digits in 2023? So let's do it. 2023. So you can erase any 2 digits, right? So like this way. So if you erase 2 and 3, you get 20, right? And then you can erase this 0 and 3, you get 22, right? You can erase this 2 and 0, you get 23. So what do you think? What is the largest number you can get by erasing 2 digits? Well, if you look at the digits that we have uh, the digit 0 there, and 2 there, and 3. And we can change the order, can only erase, right? So you can see that the largest number you can create is 23. It's the largest number. So the answer is 23, right? Okay. So now number 10. What is the biggest odd number less than 100? Now, this is interesting because it's the biggest, right? Odd number. And then less than, right? So it's not biggest odd number. But is there a biggest odd number? No, right? Because this list of odd numbers, right, starting from 1, right? 1, 3, 5, 7, 9, 11. It continues with no end. So there's no biggest odd number, right? But we need to find out the biggest odd number less than 1,000. So if you continue this list, what would be the odd number closest to 1,000, right? Now 1,000 is of course even, right? Now how do you know a number is even or not? Of course you can try 1,000 apples, right? You buy 1,000 apples and then try to divide them into 2 equal pies. There's a hard way. The easy way is that there's a test, right? A number, any number is even if the last digit or the units digit, we call this the units digit, right? Or the ones digit. And that's actually maybe a better name, ones digit, because we have this actually the tens digit is the hundreds digit, and the next is the thousands digit. So this is the ones digit, right? But then some actually use the units digit, right? Right. So if the ones digit is even, right, then the number is even. Now, how many digits are there? Even digits. So we have 2, 3, sorry, no, 3, right? 4, 6, that's not a nice 6, right? 6, 8. But what about 0? Is it odd or even? So you take 0 apples, can divide them into 2 equal heaps. Well, it's not easy to think, right? 0 apples, no. I mean, there's nothing there, empty, right? Well, 2 is even. For the moment, you just need to accept it, and you can think about it. Why is it even? So why 0 is even, right? Now, some questions you may not find answers right now, right? So you have to keep a list of questions that you have actually no answers, right? That's okay because we don't have answers to every question, right? So we keep trying to find answers to our questions in this list of questions which we do not have answers for, right? Anyway, so if a number ends with one of these 5 digits, right, it's an even number, others are odd, right? Of course, then 1,000 is an even number because it ends with 0. And then what is the odd number closest to it? Well, we have 1 before 1,000, which is 999, and that does not end with an even digit. It ends with an odd digit, so it is an odd number, right? So the biggest odd number less than 1,000 is 999. Okay. Okay. So that's the last question in the easy section, right? So In the next video, I will actually I'll discuss the median questions, right? So until then, take care, right? So I'll meet you in another video, right? And I will discuss the median questions. Okay, thank you.